Okay, maybe an example might be a little bit more complex here. We have the function y equals 3x squared take x, and we want to find dy on dx. Okay, so this is terminology that you'll use in terms of the derivative. Okay, dy on dx, just like f dash x, means the derivative function. So using first principles, the way that we're going to do this is put x plus h into the equation. All right, we're using our equation up here. So we've got the limit as h approaches 0 of 3 times x plus h squared take away x plus h. So this, what we've got here, that I'm drawing a circle around, this is f of x plus h. What we've done is we've got x plus h and we've put that everywhere there is an x in this original function. Okay, now what we need to do is take away from that the original function of x. Okay, now it's important we put this part in brackets. Okay, now I'll show you why first. If we don't put the bracket there, I'm going to have 3x squared take x. But what we don't realize here is that we're actually taking away this value here too. Alright, so it's important that we put perhaps f of x plus h and f of x in brackets so we can clearly distinguish between the two, and all of that is on top of h. So let's expand and factorize. So we've got our limit as h approaches 0. Now I'm going to leave this 3 out the front and we're going to expand this. We've got x squared plus 2xh plus h squared. Okay, that is take away x, take away h. Alright, that minus is applying to everything inside the brackets. And then we're going to expand this. We're going to have take away 3x squared plus x. Okay, and all this is on h. Alright, now we need to expand the bracket out the front there. So our limit as h approaches 0, we've got 3x squared plus 6xh plus 3h squared. Take x, take h, take 3x squared plus x. I'm just going to move across a little bit. Okay, and all that's on top of h. Okay, how can we simplify this? Here we have 3x squared, here we have minus 3x squared, so they can cancel. Okay, here we have minus x, here we have plus x, so they can cancel. Now we start looking at common factors. Okay, so our common factor should always be h. Alright, so let's go down a little bit. So our limit as h approaches 0, if we've pulled h out the front, what we're left with in the brackets then is 6x plus 3h and take 1. Right, and that's over h, so the h at the top and bottom can cancel. Now our limit as h approaches 0 of 6x plus 3h take 1. Now remember, 3h is approaching 0, so our answer is going to be 6x take 1. Okay, so dy on dx is equal to 6x take 1. This is the slope function. So the trickiest part where most people get caught out, okay, is make sure you're putting x plus h everywhere there is an x, okay, and make sure you're putting brackets around the fx part, so you remember to take away everything inside there. Alright, hope this helps.